My name is Rowan, and I will be talking about the atomic radius. The atomic radius of a chemical element such as lithium or neon is a measure of the size of its atom. It's the typical distance from the center of the nucleus to the boundary of surrounding cloud of electrons. In other words, it's the measure from the center of the circle, the nucleus, to the outer boundary of the circle, the electrons. But the outer electrons are not clearly defined, so it's not as clear-cut in measuring as on the picture to the right. In order to find the atomic radius, you take two of the same elements, let's say hydrogen in this case, and you put them as close together as possible without them fusing, and you measure the distance from the two nuclei and divide that by 2. This will give you the radius of the atom. This is just one of the many methods of finding the atomic radius. Next, I will talk about the trends along the periods of the periodic table. On the table to the left are the elements of period 2 listed. The table shows the atomic radius of the element and the order in which they come on the periodic table. These data points are graphed on the right. The farthest point to the left is lithium, and the farthest point to the right on the graph is neon. As you can see, the trend is that the farther you go on the period, the smaller the radius gets. This is because the farther you get to the right on the period, the more room there is to add additional electrons without adding an energy level. A common misconception is that people think since you can add more electrons, the radius will get bigger. But actually, since there are more electrons, there are more protons. So the protons pull the electrons closer to the nucleus, making it tighter and lowering the radius. Next, I'll explain the trends along the groups of the periodic table. On the table to the left are the group called alkali metals listed. Their atomic radius and order in which they appear are listed. The data points are plotted. The farthest point on the left of the graph is hydrogen. The farthest point to the right is calcium. The trend is that the radius gets bigger and bigger as you go down the group. This is because, unlike with the period, you add another energy level each different element you go down the group, which is why it increases in size. There's only one exception to this rule. That is that with the inner transitional metals on the bottom of the periodic table, is that the electrons are added to the inner shells where the outer shells stay constant. So there is very little difference in radius size between these inner transitional metals, which is located on the bottom of the periodic table. These are my sources, and I would like to thank Ayana, Emma, and Jack for being supportive group members, and Miss Kinsella for giving me help when I need it, Koki for providing me with helpful sources, and Jack Emerzino for providing me with moral support. Thank you.